All right, so right now we're going to graph cotangent of theta. Cotangent of theta, we just said, is 1 over tangent theta. There are the reciprocals right there. Or we could think of cotangent as cosine over sine. Since cotangent has a denominator, that means that there's going to be, with theta in it, that means there's going to be restrictions on our domain. What number are we not allowed to divide by? 0. And that means wherever sine equals 0, those angles are going to cause us a problem. What angles, theta, have a sine of 0? 0 is one of them. What else? Pi, 2 pi, and so on. Basically, everywhere the unit circle crosses the x-axis. So 0, pi, 2 pi, 3 pi, 4 pi, and all the negative integer pi's, all right? So negative 1 pi, negative 2 pi, negative 3 pi, and so on. All right, so to graph this, we can kind of graph this the same way we went about graphing the other trig functions. We're going to draw our theta axis and our y-axis, okay, right there. And we could put some tick marks on here. I'm not really measuring, even though I have graph paper, but whatever. 1, 2, 3, 4. So these tick marks are going to be labeled with the quadrantal angles like always. So we got negative 2 pi, negative 3 pi over 2, negative pi over 2, 0, and all their opposites. Now, based on the ratio that we know cotangent to be, you guys should be able to figure out where cotangent has a 0 or an x-intercept and where cotangent has an asymptote. So what can you guys tell me? Give me anything. Where does cotangent equal 0?
0, 0.
Does it equal 0 at 0? It's undefined. Didn't you just tell me sine equals 0 at 0? And then cotangent's being divided by sine. So that means at 0, cotangent has an asymptote. Exactly. So we're going to go over there at 0 and we're going to draw an asymptote. So let's use orange, I guess. So cotangent, we're going to have a vertical asymptote at 0. What else can I add to my graph? Asymptote at pi. What else?
2 pi.
Another one at 2 pi. What else?
Negative pi.
And then all their negatives at negative pi, because that's actually going to be coterminal with pi anyway, and at negative 2 pi. All right, now what? What else can I add to this graph?
The skeleton of tangent.
We don't need to draw the skeleton of tangent because it's going to kind of mess us up. But I know what you mean because we did that for the other cosecant and for secant. What else do we know, Dylan?
The zeros.
The zeros. Where does cotangent equal 0?
Pi over 2, pi over 2.
Yeah, at pi over 2, at 3 pi over 2, and the negatives. Negative pi over 2 and negative 3 pi over 2. All right. What else do we know about cotangent? I may not have the tick marks for everything, but do you know where it's positive and where it's negative between which angles? What can you tell me about this part over here of the theta axis right here between 0 and pi over 2? What quadrant is that? 1. And what's cotangent in quadrant 1? Positive or negative? It's positive. In fact, right here, halfway between 0 and pi over 2, what angle is that? 45 degrees or pi over 4. And what's cotangent equal there? 1. So really, it passes through this spot right here, right? This is the other increment of pi over 4. That's 3 pi over 4 at the next pink tick mark. What is cotangent equal there? Negative 1, right. It's basically negative in that whole second quadrant. This is the second quadrant right here. all right, in between pi and 3 pi over 2. That's quadrant 3. And that pink tick mark basically represents 5 pi over 4. And what's the cotangent of 5 pi over 4?
1.
1. It's 1 again. And what's the cotangent of, right over here in between 3 pi over 2 and 2 pi, is 7 pi over 4. That's quadrant 4 right there. And what is cotangent equal at 7 pi over 4? -1. So these pink points we're going to pass through. This red one's a point of inflection, and then it turns and goes down right over there. Same right here. So we got 2 branches, and then that pattern just continues because it's periodic. So it's a little bit different than tangent in the sense that the asymptotes and the zeros are in different places, right? But they're both positive and negative in the same places. So this is what we got to watch out for, okay? This space between 0 and pi over 2, where I just marked in yellow, that is quadrant 1. They're both positive in quadrant 1. So if you look at your tangent graph, it's positive in this area, but the graph looks like it's going down. I'm sorry, it looks like it's going up in tangent. Right now in cotangent, my graph looks like it's going downward. Okay? So tangent, I'm going to draw tangent in yellow in a second. Tangent has a 0 right there. It's going up, and then it hits an asymptote. So they have completely different location of zeros, completely different location of asymptotes. They flip-flop, but they're both positive in the same quadrants and negative in the same quadrants. That's where it gets a little tricky, and that's a good way to check if you did it correctly, okay? Next thing, what about the domain and the range of cotangent? Anyone have any idea what the domain for cotangent would be? Go ahead.
All real numbers such that theta does not equal 0 plus pi n or nes.
Pi n, where n exists in the set of integers, nes. All right, and what about the not the range, the range, combined domain and range into one word. What's the range?
All real numbers.
Yeah, negative infinity to infinity, or all real numbers, whatever way you want to look at it. Okay? Not so bad. It's going to work very similar to how tangent works. Okay? So we're going to try an example. Let's make something up. Let's do y equals -2 cotangent of, let's do 4/3 theta plus pi over 5 plus 1. So I'm going to pause this, and you guys can give it a shot. All right, so far all we did was we found the period. The period, like tangent, is going to be pi over b. So when we divide by 4/3, it's the same as multiplying by 3/4. So we get that the period is 3 pi over 4, which makes a half a period 3 pi over 8, with a common denominator with the pi over 5 over there, the negative pi over 5, gives us 40. So 15 pi over 40 is a half period. Then we changed negative pi over 5, because it was to the left pi over 5, into negative 8 pi over 40, and continue to add 15 pi over 40 each step of the way to get the next tick mark on the graph. So everyone's okay on the theta axis? Yeah? All right, now that we know where our graph changes from negative to positive, we can draw in our y-axis after the fact. So somewhere over there should be your y-axis. Now I could even add in a couple more tick marks because of the stretch or compression that we're dealing with right now. And I could also add in where the sinusoidal is. So let's see. Over here, that could be 1. Then that would be 2. That would be about 3. That's 0. There's -1. Whoa. -1 something. Why is it so long there? There we go. -1, -2, and -3. Something like that. All right, so where am I drawing my sinusoidal axis? at 1. So going across horizontally at y equals 1, we have our sinusoidal axis. Okay. Now, where do I draw zeros and where do I draw asymptotes for cotangent? Where do we start? And what goes there? Right, this one starts with an asymptote. After that, we hit a 0. Then we hit an asymptote again. Hit a 0. And an asymptote. Are we good up to there? Now it's negative, and there is a 2 out front, so that's your stretch or compression, depending on the number out front. So what do we need to do? Halfway between, what happens?
You're gonna put a point at, okay, so halfway through between -8 pi over 40 and 7 pi over 40, you're gonna put a tick mark at -1.
Okay, good. Now, just to kind of explain again, cotangent is usually positive in quadrant 1, then it's negative, then it's positive, then it's negative. So usually the branches would be in those purple areas. However, we have a negative sign out front, so that's going to be a vertical reflection. So that means that it's going to be down here, down here, and up here, because the reflection up, down, puts the branches are going to be in those colored in areas. And because of what, who was that, Katie, you said that? Yeah. Because of what Katie said, the vertical stretch, from here halfway between, I'm going to go down 2 units. So it's going to be near the x-axis. Probably not exactly there, but close to it. It's going to be right about here, exactly between 7 pi over 40 and 22 pi over 40. We're going to be up here at 3. So then you draw your branch, something like, well, that second one missed. Something like that. Okay, same idea in between these two. We're going to hit -1, a stretch of 2, and we're going to hit 3 right in between a stretch of 2. So we have another little branch happening in there. So it's nice and vertically stretched by a factor of 2. Obviously, yours might look different depending on how you did your tick marks, how you did your spacing. Now for the domain and range, what do we get for the domain? All real numbers. Such that theta does not equal. Go ahead.
-8 pi over 40.
-8 pi over 40. Is that where the first asymptote was?
Yeah.
Good. Plus
30 pi over 40n.
30 pi over 40. That's how far it was to the next asymptote.
Yeah.
Looks good. N. Good. Where N exists in the set of integers. And then last, the range. All real numbers. So now you officially know how to graph all 6 trig functions, which means you need to practice them